So this is a quick and easier way to explain how to solve this shit from lab today and how to apply it to all the other equations that you need to solve, or the concentrations, whatever. But welcome to my classroom, everyone. So I have down all the equations that we need to solve for the concentrations that we want, and I color coded them so you know when I'm going to use which one and which, and it's not as difficult. And I numbered them the same way they are numbered from lab, so you can literally write this down while we go. So starting off, we have our fluorescein total equation, number 13. I duplicated it because we're working off of that, but we want to find different concentrations of each of these, and we're using mole fraction by doing that, but we're reversing it, if that makes sense. So we want to do this for every single one of our concentrations, and we're going to start off with our H3 Flu plus. So we want to get it by itself. So we're going to divide it over, easy peasy. We all know how to do this part. You can kind of skip ahead if you don't want to hear me talk on how to do this. And we know that when we divide, we got to divide by the whole thing. Well, looking at that shit looks ugly if we leave it this way. It's just going to be so much harder to solve if we keep it all connected. So we're going to separate that out because we're trying to make this shit as easy as we can. And I'm just going to work through it. Okay, halfway done. I'm lying. There's so much more to do. So obviously we said this in class, when these same two concentrations are on top of each other, it is equal to 1. So I'm going to go ahead and just change that now because I'm not rewriting that whole thing. But here it is. 1 plus this concentration plus this concentration plus this concentration. We need to be able to reduce it down by using our 10, 11, and 12 equations. So a good example is this first one right here. H2 flu and H3 flu plus. It's literally over here too. And we can sub it in, but we just have to get it by itself. And obviously to get it by itself, we would have to put the H plus under Ka. So our new equation is H2 flu over H3 flu plus, I'm just writing on the side, this isn't going to be a part of the actual thing, just to show you, is equal to Ka1 over H plus. We see that? It's pretty, it's cute, it's simple. The other ones get worse. Okay, so we can then change this part right here into what we just wrote down, which was that it was equal to Ka1 over H plus. Now we have to do that to the other two. So I'm going to erase this purple work. I hope you had it written down, and I hope you understand why I did it. We have the value for Ka, and we want to be able to use Ka to solve what we're looking for. So now we're on to the second part, which is H flu negative over H3 flu plus. And obviously we don't have a equation that matches this with any of these, but we do have a flu negative here. And we know that this denominator H2 flu can connect to the missing denominator that we want. So we are going to, on the side now, or whatever, we have our first K2 equation. And I know you want to think like you want to get the H flu by itself, but no, we want to be able to connect it from H2 flu to the number 10 equation. So in this way, we're going to separate our H2 flu by itself. And obviously, it will look like H plus times the concentration of flu negative over our Ka2 value. Okay, and that's for H2 flu from equation 11. Okay. From there, we can then start going into our Ka1 equation, right? Right? And we already solved for our H2 flu, and we can just now sub this whole thing into that equation. Okay? So I'm just going to do that real quickly. H plus times H plus times the concentration of HFLUW, flu, and Ka2 times the concentration of H3 flu plus from up there. And that's basically it. Now you just have to separate our H3 flu and our H flu negative, because we're trying to match up here, remember? And then we will get our answers. So I'm just going to simplify H plus square times H flu negative over Ka2 times the concentration of H3 flu plus, which is equal to Ka1. Remember, Ka1. And that's going to look like Ka1 times Ka2 over H plus square is equal to our concentration of flu negative over our concentration of flu positive. And remember, it matches up here. That's what we wanted this whole time. I'm going to color it different just to show you that I first started off with the 11th equation. And I'm going to get rid of that and just put it in here. There we go. Good job. We're honestly almost done. Literally almost done. One more to go through. I think at this point you can kind of guess what we're about to do. We're about to start with 12, go to 11, and then go through 10 for our flu 2 negative over H3 flu plus. Because flu 2 negative is only one, so. Where the fuck is my green? Oh, there we go. So, again, you might want to separate flu 2 minus by itself, but we want to be able to connect everything with each other. So the denominator is going to match with the numerator from the last. The denominator is going to match from the numerator from the last. So we want to separate the concentration of H flu negative. Okay, so from 12, that looks like H flu negative. The concentration is equal to H plus times the concentration of flu 2 negative over Ka3. And then we relate that back to our 11th equation, and that would be Ka2 is equal to H plus. You get the point, so I'm not going to rewrite the 11th equation. I'm just going to plug it straight in, my H flu negative, which is H plus times flu 2 negative over Ka3 times the concentration of H2 flu neutral. Okay? And again, you might want to separate flu 2 negative, but we're not. We're doing the one at the bottom. So now that's going to look like what? H2 flu equal to Ka2 times Ka3 over H plus square times, what the fuck? Oh. What the fuck did I just do? Okay. I know I did wrong. Yeah, what the fuck did I just... No, I'm doing it right. Okay. Square flu 2 minus Ka2 times Ka3. Okay. Remember, we subbed in the 11th equation. Now, because we're so close to having our H3F flu plus, we're going to do it because we're almost done. And it's almost worth it. Okay. Ka3, 1 is equal to the concentration of H plus times the concentration of H2 flu over the concentration of H3 flu plus, we're going to sub in our last equation for our H2 flu, and that's going to be H plus times H plus, H plus square times H2 flu. Wait, what the fuck? Sorry. Times flu 2 minus all over Ka2 times Ka3 times the concentration of H3 flu plus. Okay? Now, we're so close. Let's get flu 2 minus over H3 flu plus by itself. And that will look like flu 2 minus over H3 flu plus equal to Ka2, Ka3, fuck, I don't like that. Ka1 times Ka2 times Ka3 all over H plus cubed over, that's it. Yeah, that's it. And so we then get our final fucking answer. Okay. We did it, y'all. It's finally fucking over. So this should be